Okay, in this lesson we are going through Chapter 8, Section 1, called Dilations. And our goal with this is to introduce or review, hopefully you've seen them before, what a dilation is and how it applies to the scale factor. Then in the next lessons we'll talk about similar figures, and eventually that will lead us into developing trigonometric functions. So today in this video specifically, we want to be able to dilate an image, both using a ruler and or on a coordinate grid, and then determine the applicable scale factor. Okay, so I would go ahead and look up this little video. We watched this little video in class, so if you watch this video, it just introduces dilations in a very quick and simple way. The idea of what it is, the center of dilation, and the scale factor, so just some vocabulary. What is a dilation? Dilation is a growth or, a reduction in the size of a polygon. It does not change the shape. So when we fill this in, dilations create different sizes. It's like when you go get your eyes dilated at the eye doctor, the circular pupil, it grows, but it's still a circle. If it were to change shape, it would not be a dilation, it just creates a new shape. So dilations create different sizes. They keep the same proportions. So if one side grows, the other side has to grow as well. And in the video, you'll kind of see that with a little school picture that's growing. And they maintain the same shape. So all the angles have to remain the same. There's an extra "the" in there. So different sizes retain the same proportions and maintain the same shape. We did a couple exploration activities. And I'm going to skip this linear one and just talk a little bit about this lower one. But you're welcome to walk through this one and look at a dilation. Notice this one's going to dilate by a scale factor of 2. The one I'm going to do down here is going to dilate by a scale factor of 1/2. So definitely on the top one, go ahead and walk yourself through those steps that it walks you through. Down here, the way we dilate a figure is, one, we have to create some points that we want to dilate that we feel like will create the shape in the end. And the easiest way to do that is to find your vertices. And I'm going to name these just so that I can talk about them specifically in this video. And I'm going to go around the polygon clockwise direction. So we've got A, B, C, D, and E. Those are the vertices. Then over here, I'm going to call this point P. We could have different centers of dilation. So the center of dilation could be over here. The center of dilation could be point A. The center of dilation could be a point maybe right here in the middle of the polygon. So the center of dilation can be anywhere. We just need to make sure that we've defined where that's going to be. Okay, so let's, on this one, I don't think it tells you where to do it, so let's do the center of dilation at P, right? And it says with a scale factor of 1/2. So I'm going to say where, and scale factor is generally used a K value. So we're going to scale it by 1/2. And then maybe I'll do another one where I'm using a different center of dilation. So essentially, again, we're going to shrink or grow this image. This is something you do in maybe an art class. And what you do is you take your ruler, and I wish I had a little picture of a ruler on here. Maybe I should find one eventually. But you take your ruler and you put the 0 wherever the center of dilation is. And I like to use centimeters because they go by tenths, and that works really easy if I want to use like a decimal, because if it goes 1 and then 4 little tick marks, I can put 1.4. So you put the 0 right at the center of dilation on your ruler, and then what you do is you put your ruler so that it's going straight over here through point B. So this is like if this was my ruler, I would just set my ruler here. Then what I do with that is I actually measure the distance between P and B. Okay, so you're going to go ahead and measure that. Now it's going to be different on mine because I'm using my video here, but mine is at 9.5. So if I'm looking at 9.5, then when I come back, what I want to do is multiply whatever that distance is by the scale factor. So I'm going to create a new line here. Let's see if we can do this. If I can make it all the way through B, or if I miss. Nice. Okay, so that's one line, right? And what we're going to do is we're going to measure it, and then we're going to cut it in half. We're going to do the same thing with each vertice. So your goal is to move each vertice half the distance to the center of dilation. And what that will do is that will change the size of the shape when we connect those dots. Okay. So if that was 9, I'm going to write it on here. Oh, well now it's probably a different length. if that was 9.5, oh, I'm so sorry, what a mess, 9.5, then my new point when I go ahead and I take my measure is I'm going to go ahead and do half of that. Now, I zoomed in a little different, so now it's at 10, so that's awesome. Mine's at 10 centimeters. So my new point is going to be at 5 centimeters. Notice that's just half the distance to B. Then I'm going to do the same thing with the next one. So I'm going to go from P and I'm going to go over to C. Pretend that's a straight line. I'm going to measure that distance. So again on mine, that's 12.5. So if I take 12.5, times it by the scale factor of 1/2, or I take half of that, I'm at 6.25. So right here. And the way we label the dilated images is we go C and then we put a little apostrophe. That means prime. So this is B prime, this is C prime. Now I'm going to move towards D. So let's hope this is sort of straight. Yes, I'm using my straight tool. So again, if I measure to D, it looks like mine is 13 centimeters, so halfway would be 6.5 centimeters. Again, notice that's just half the distance. That would be D prime. I do the same thing with E. Okay, there's a line. And E looks like it's at 10.5, so I'm going to go at 5.25. That would be E prime. And then lastly, I need to do the same thing with A, because I skipped vertex A here. Oh, that's a line. Okay, well, maybe that one's not working. Okay, drawing it by hand, a little crooked. Okay, it's good. If we look at that, that one's 8 centimeters for me, so I'm going to put a point at 4. Now notice if I connect these dots, so, let me label A prime. It's really important we're labeling these so that we understand which one's the dilated image and which one's not. Then we can go ahead and connect these, and you'll notice that this image is oriented in the exact same way it was before. The angles are the same. The relationship between the side lengths are the same proportion. All it did is shrink the image back. So anytime your scale factor is less than 1, it's always going to shrink the image back. If this was a scale factor of 2, then we would take this distance and we would double it. Now that would go off the page, so I didn't do that direction, but essentially that's what we're looking for. And if you were to measure the side of this now dilated image, right, or these distances, maybe I should label one of these. So this one, the total here, and this you'll see this kind of on your assignment today, was 10 centimeters, and this one right here was 5 centimeters. So if I was given the image and I was asked to determine what the scale factor was, I would just take my dilated image of 5, so the dilated image, and then you're going to divide that by the original. And that gives me that scale factor. So I knew it became 5 and it was 10, so the scale factor must have been half. Got half as small. Now if I change the center of dilation, so in purple I'm going to look at a different one. If I do center of dilation, I'm using the same image at, let's say, point E, and scale factor, or K equals 1/2 again. I would do the same thing, but instead of putting my 0 here at the center of dilation at P, I would put the 0 here, my center of dilation of E, because that's what it asked me to put it. So when I do that, again, I just measure the distance to each vertice. So if I measure this distance right here, again, that's much shorter of a distance, but now I'm looking at, say, 3 centimeters. So when I put my new point in, I'm at 1.5. Now that's D prime when my center is at E. Again, I would measure from E to C, so I would measure this distance to each vertice. That's 5 centimeters for me, so at 2.5 I would go ahead and put C prime. Then I measure from E to B, and again you can pause this video if you need to do your own measurements. That for me is at 5.5, so I'm going to go 2.35. There's B prime. And then again, I measure A to E, so that's my last one. I'll show you right there from A to E. And I'm going to go halfway on that one, so that's 1.75 for me. Notice now I could connect these, and you've created that same size shape that my red one is, Still dilated by a scale factor of 1/2. It's just in a different spot because our center of dilation was at E and the center of dilation over here was at P. So depending on where your center of dilation is, that's where the 0 on your ruler goes. Then you measure and you multiply by the scale factor. So in this case, we shrunk it in half. Okay. Turning over to the next page, a dilation, right, gives you kind of a definition right here. It always uses a center of dilation and a scale factor. So we want to make sure that we know what those are specifically. Again, the center of dilation is a fixed point, so we need to know what that is. And then the scale factor is the ratio of the new image to the original. So it kind of tells you that we always take the, looking at the original figure has a length of 2. If the new figure has a length of 4, we do the new one, like we just said, the dilated image over the old one, and it tells us what it changed by. The term for a growth of an image is an enlargement, and it enlarges any time the scale factor is greater than 1, or sometimes scale factors are given in percentages, so we could also say greater than 100%. So if it grows like 115%, then it's going to grow. If it's between 0 and 1, or if it's less than 100%, then we're looking at a reduction of the image. Okay, there's a specific example right here we can read through. I'm going to go ahead and jump to the examples, so again you can read through that first one. This one right here, the way we dilate it on a coordinate grid, even easier, we don't even need the ruler. So we dilate a triangle with vertices A, B, C by a scale factor of 2. So this time this is a scale factor of 2, it's going to grow, and the center is going to be at 0, 0. All the ones we do this year, the center will be at 0, 0, so we don't have to worry about adjusting for that. So what you're going to do is you're going to draw the triangle and label its vertices. So if I draw the original triangle, here's A, B is at 4, 0. Again, you want to label it because you're going to put a dilated figure on here too, and we want to be able to tell the difference. So here's my original triangle. Okay, just plotting those points. And I'm going to write the points over here just so you can see what's happening to each of these. And it's just good practice when you're starting with these so that we don't make too many crazy mistakes. And I'm going to dilate each of the points. So I'm going to draw little arrows. If I dilate this by a scale factor of 2, which is what it asked me to do, I'm going to multiply each of the elements of the value, the point, by 2. So A prime, when I dilate it, would be multiplying 0 by 2, which is 0, and 0 by 2, which is 0. If I dilate point B by 2, then that's going to be 8, 0. And if I dilate or multiply C by 2, that's going to be 8, 6. Okay, so anytime you have a point, and I'm going to write this in kind of weird notation, I feel like this is number 1 on your homework, but if you're given any point x, y, and you dilate it by a scale factor of k, any k value, then all you do is you take p prime, right, whatever that new point is, it's just k times the x, k times the y, and that gives you that new point for your dilated image. So let's go ahead and graph these new points. Again, A is at 0, 0, so I'm going to put A prime right next to that. B prime is at 8, 0, so it's out here. C prime is at 8, 6. And you'll notice that when you're done, those new points create an image that lie on the linear paths from the old one. So if you ever find that your image is like going up here and then down, right, it has the wrong angles. You changed angles and your shape. We just want to change position. Okay. Really quick, let's do 2 more. So this one doesn't have an image. I apologize, it goes into the graph. It says you're using word processing software to type the online school newsletter. You change the size of the text, right? So not the format, just the size, in one headline from, so that's important that you know where it comes from and where it's headed to, from 0.5 inches tall to 1.25 inches tall. What is the scale factor of this dilation? So again, remember, if I want to know how it grew, I take the dilated image or length and I divide it by the original length or size. Okay, so in this case, the dilated, it ended up at 1.25 and it started at only 0.5. So we know that we should get something right that's greater than 1 because this is definitely an enlargement. So we just go ahead and divide that and we end up with 2.5. So this grew by 2.5. All right, one more example really quick. If you feel like you've mastered it, you can stop the video here. But again, if we want to dilate a parallelogram, here's some vertices. The vertices are also already graphed. This time it's by a scale factor of 1/2. I'm going to change that just to show you kind of a percentage one. So let's say we did the scale factor. This is going to be a little weird. Scale factor of, let's say we do 25%. Now if it's a percentage, when you do a scale factor, you're going to just change it to a decimal when you multiply each of the pieces. So that's like 0.25 or 1/4. So let's say I take my original points A, -4, 4, B, 6, 6, C, 6, -2, and D, -4, -4. If I'm looking at these points and I want to dilate it by 0.25, again, like we talked about above, we just multiply each of the elements by 1/4. So if you take -4 and times it by 0.25, or take 1/4 of that, you get -1. If you take 4 and multiply it by 0.25, again, you get +1. Same thing with this one. So if we do 6 times 0.25, and these ones are going to be a little messy. Oh, I wrote A twice. Let's do a B. B prime, this is going to be 1.5, 1.5. So we're just multiplying it by 0.25. C prime, again, 1.5 for that one. If I do -2 times 0.25, I get -0.5 or 1/2. And then lastly we have D prime. So if I take 1/4 of -4, multiply that by -4, I get -1. So let's go ahead and graph that. A prime, again, is at -1 up 1, so I'm going to graph A prime right there and label it. B is at 1.5, 1.5. C is at 1.5, -0.5, C prime. And D prime is at -1, -1. Now notice when I connect these, the lines of my new image need to be parallel to the lines of my original image. So notice it's just going to be the same shape but much smaller because it's only 25% of that shape. Again, if you find that your line suddenly looked like this and it changes shape, then go back and fix the point that made it change shape. Okay?